Welcome to ACI, the Network Made Simple learning series. In this video, we will cover
Module 4, Configuring L4 to L7 Services. Chapter 4, F5 Integration using Service Center App. As covered in previous chapters, Cisco ACI provides automated Layer 4 to 7 services insertion for firewalls, load balancers, intrusion prevention systems IPS, and many others, using a feature called Service Graphs. In this chapter, we will take Service Graph and automation further by configuring F5 server load balancers from ACI using the F5 Service Center app. The F5 Service Center app can be downloaded and installed on APIC, and very soon on Nexus dashboard as well. It works with unmanaged service graphs, which means it does not require device packages, and it leverages APIC and F5 RESTful APIs to automate server load balancing configurations, consolidating service stitching and visibility on APIC. In today's video, I will first show you how to install and configure the F5 Service Center app, and then how to configure and monitor an F5 server load balancer from ACI. We will do this through 3 simple steps. Number 1, we will install the F5 Service Center app on APIC and configure the virtual server and server pool from ACI. Number 2, we will configure a service graph to stitch our F5 Big IP server load balancer. Number 3, we will configure our F5 Big IP addresses from ACI using the Service Center app. As you may know, there are multiple options to implement server load balancing services, which may include source NAT, 1-ARM, and 2-ARM modes. In this case, I'll go with the 2-ARM option using the ACI Fabric as gateway. We will be using a single VRF, and we will not use source NAT. Therefore, policy-based redirection will not be necessary. In our scenario, we have a pre-configured tenant with 1 application profile and 2 EPGs communicating through a contract that allows all traffic. The tenant name is TNT F5 Demo, and it has a single VRF. The application profile's name is App F5 Demo, and its 2 EPGs are EPG clients and EPG webs, each with an associated bridge domain. As covered in previous chapters, both bridge domains have ARP floating enabled to make sure we can successfully insert L4, L7 services between them. In my environment, I also have a brand new virtual F5 Big IP installed. Except for its management IP, it has a blank configuration and a single default partition called Common, as you can see. In terms of endpoints, I have 3 web server VMs that will be part of my F5 server pool, and 1 client VM that I'll use to access such web services through a virtual IP. The client VM is assigned to the EPG clients, which uses the 192.168.1.0 subnet, and the web server VMs are assigned to the EPG web servers, which use the 172.16.0.0 subnet. Are you ready? Let's begin our configuration then. First, I need to install the F5 Service Center application. So I will go to the Cisco DC App Center and I'll proceed with the download. Once it's downloaded, I will go to my APIC, click on Apps, and Add Application, browse the file I just downloaded, and hit Submit. This might take a while, but once the application is installed, you just have to enable it and it should be ready to use. I will then associate my F5 Big IP load balancer to ACI. I just need to open F5 Service Center and provide the Big IP address along with its admin credentials. Now, if we go to the L4, L7 App Services tab, You have two options to configure your BIG-IP virtual server and server pool from ACI, either through the basic option, where you can download and use a predefined template set and simply fill out the requirements, or through the advanced option, where you provide the required values as part of a script. I will do it through the advanced option at this time. I will start by defining a new partition for my BIG-IP. I will call it F5 demo, and then I will also create an application for my virtual server list. I will call it Web Servers. I will now edit the script below, indicating the virtual IP the client must reach in order to get to the balanced web servers, and the IP for each of the web servers in the server pool. I'll now hit Submit. It seems we are ready with the F5 configuration, so let's move to the second step and configure our service graph just as we know it. I'll go to our tenant and I will expand the services option. I will then define the L4, L7 services for the load balancer by right-clicking over devices, and then create L4, L7 devices. Next, indicate a name to identify the device. In my case, I will call it F5 Load Balancer. I will then select ADC as the service type since we are using a load balancer. Then, I will specify this is a virtual load balancer, and I will select the VMN domain where my BIG-IP VM is located. In the right panel, I will now click the plus sign over devices and select my BIG-IP VM from the list. Now, I will add the VM adapters that my load balancer concrete device will use. Remember, we will be using a 2-ARM configuration and a single load balancer device in this case. Finally, I will go to the cluster interfaces section, click the plus sign, and create a logical interface for my server load balancing service. I will start with the internal one, which will be facing the server pool, associating it to the corresponding concrete device VM adapter. And then, I will continue with the external one, which will be used for the client side. In this case, my F5 VM is running on a single link ESX server. However, it is important to mention that if you are using VPC and LACP on your VMware host, you'll need to add your lag policy based on your VMN domain configuration right here. To finish this device configuration, just click Submit. The next step, as you already know, is to create a service graph template. Just right-click on Service Graph Templates and choose the Create L4, L7 Service Graph Template option. Define a name for the template and drag and drop the device we just defined. Then select 2-ARM based on our scenario and click Submit. The last step is to associate our L4, L7 service graph to the existing permittal contract so that ACI can redirect traffic to the load balancer. So, in the application profile topology, I will just drag and drop the L4, L7 icon to the contract and then associate the EPG client bridge domain with the external logical cluster interface, and the EPG web's bridge domain to the internal one. And we are done. Hopefully, all this was very familiar to you based on the previous chapters. So, is there any other configuration missing? Well, as part of step 3, we still need to configure an IP address for each of our F5 BIG-IP interfaces. So, we will now go back to the app section and open the F5 Service Center again. I will click on the L2, L3 Network Management tab, and you'll see the VLANs that were automatically assigned by ACI to the load balancer internal and external logical interfaces based on our BMM VLAN pool configuration. From there, go to the Select VLANs for L2, L3 stitching section, and select both VLANs, moving them to the selected area and then click on Manage Selected. We will simply configure an IP address for the big IP network adapter facing the client side and another for the server side. And then, voila, we are ready to test this. Let's go to the client VM, open a web browser, and type the virtual IP we configured on F5 Service Center app, and it works as expected. We could always go to F5 Big IP console and verify that the configuration was automatically pushed from APIC, including the partition, server pool, and IP addresses. However, one of F5 Service Center objects is consolidation, right? Therefore, instead of accessing two consoles, we can monitor everything directly from APIC now, including VLAN information, virtual IP information, and node information. This way, we can very clearly see the status of every load balancer element and its relationship with EPGs, application profiles, and tenants. If we need further detail, we can also use Visibility Dashboard, where you can see the status of your virtual server and specific of its configuration, including load balancing type, rules applied, statistics, and endpoint details and connections. Powerful, right? And the best part is that you are not sacrificing any functionality on your F5 load balancer. If you would like to learn more about Service Center and even test it without an actual ACI or F5 implementation in your environment, there's a great interactive simulator you can use, which is available at this link. This is only a taste of ACI's open APIs and its rich ecosystem. Although I just showed you F5 integration today, the same could be applied to more solutions and vendors by installing other apps available for download in the Cisco DC App Center or directly through Nexus Dashboard. Remember that when you use Service Graph, you have an automated way to stitch L4, L7 services, such as load balancers and firewalls to ACI. However, by adding apps such as F5 Service Center, you can also directly provision your load balancers from APIC, extending its automation capabilities and centralizing visibility without sacrificing features.
ACI provides you with a better, simpler, and secure network, any size, anywhere, and on any cloud. If you want to learn more about other common tasks and how ACI radically simplifies network provisioning and operations, please watch the rest of the videos in this series. Thanks for watching.